Hi everybody, my name is Moshe Zadka. My website is cobratism.com, where you can find every way of getting in touch with me known to humankind, and today I'm going to talk to you about writing Prometheus Exporters. I would want to start with an acknowledgement of country. I live in the San Francisco Bay Area Peninsula, which is the ancestral homeland of the Ramaytush or Ohlone people. We're going to talk about writing a Prometheus exporter. We need to think about what Prometheus is so that we can think about how to export it to it properly. Prometheus is a metrics collection aggregation engine. It also does a few things on the back end with the metrics that for us we don't really care about because we're writing an exporter, so we care about the intake of the metrics. The intake of the metrics is done by pool-based. There's in general two ways of grabbing metrics. Someone has to start, right? Someone has to make the first step. Some systems use push-based, where the local thing that has the metrics sends them to the aggregator. Prometheus is the other way, which is pull-based, which means the aggregator is going to connect to us. In Prometheus' case, over the web, so it's going to expect a web API and grab some data. Those data are going to be time series data, which means it's going to be numbers labeled by some things, and that's what Prometheus expects. So now we know what Prometheus expects. Let's figure out how to give it. So we're going to write an exporter, meaning we have a service already, but that service, some services have started just having Prometheus support built in, which makes sense. Prometheus is getting pretty popular, and if you're just writing a service from scratch, you're like, probably a lot of people want to monitor it via Prometheus. I'm just gonna have Prometheus support built in. But some services, for any number of reasons, don't have it. But what we do have to rely on, that the service still has a way to get the metrics out, right? We might have to beat it out of it, but there is some way, right? If we torture the service enough to get some numbers out of it. The exporter is just a facade. It's getting numbers from this service that we care about monitoring, and send it to Prometheus. It's not magic. It can't figure out how the service behaves. It needs the data from the service. What it's good at is at translating from whatever way of the service has to Prometheus. If you're gonna write an exporter, you'll probably want to test it. Of course, unit tests are important, but are not the be-all and all. You actually want to see how it looks. So at the very least, you'll probably want to configure a small Prometheus of your own to monitor your test exporter and see that everything works together. This is an example of a minimalistic Prometheus configuration. Of course, realistic Prometheus configurations will usually be more complicated, but this is a good example, and this is how you're going to probably write a small configuration to test your own. You'll explicitly put your IP or your host name, if you do have a host name, so that Prometheus can connect to your exporter and you can see how the data looks. You're going to export things to Prometheus. You probably want to know what kind of things Prometheus expects it knows about. The maybe simplest thing you can tell Prometheus about is a gauge. A gauge is a measured instantaneous value. And my favorite example for that from the real world is temperature. Right? If you have a thermometer or some other way of monitoring temperature, you can check it and see what number it says. Right? If you put a thermometer right now outside my house, it will say something like, I think, 10 Celsius. If I was in Sweden, it would probably say a much lower temperature. I'm guessing below freezing, but I hope you all are staying safe. And, temperature might be a realistic thing for you. If you're monitoring a server rack, right, maybe it's important to know what temperature each server is, but that's usually not what we're going to write an exporter for. So a much more realistic example that you'll actually be dealing with is memory usage. If you think about how programs work, right, they allocate memories and they maybe release some memories and they allocate some more, then they release some of it. If it keeps going up, probably not great. That's basically what a memory leak looks like. If it doesn't keep going up, right? If it stays the same or goes up and down, then that's good. Either way, you can't decide if it's good or bad, right? Your job is probably to get this number in. But this is a good example, right? If you have some way of getting the memory usage of the app, you'll want to present it as a Prometheus gauge. Slightly more complicated is a histogram. A histogram is something that deals with samples, right? If you think of a shop, you can take each customer that goes in and you can ask how high that customer is, how tall they are, and you'll have some series of numbers. And the important thing is that maybe you have a group of 5 customers coming in all at once and you have 5 samples of different heights, and maybe there's like an hour with no customers, and then one known customer comes in. You don't know exactly how many you'll get at any given time, but you'll have some amount, maybe 0 at any given time. And every customer can have a slightly different height, right? Like I'm approximately 165, but probably like 165.3 centimeters or something like that. You obviously don't want that resolution, because then you'll be sending unbounded amounts of data to Prometheus. So samples are more or less synonym with histogram, because you're going to bucket the samples. You can control the size of buckets, but you're going to basically say how many things in each bucket are. And usually that's good enough, assuming that you're not monitoring a store. Probably a more realistic example is request latency. At any given point, you can have a lot of requests or a few requests, but either way, each request would have some latency associated with it, and that histogram is, of course, super useful to know what's going on with your service. Then there's a counter. A counter is possibly like one of the subtlest thing in Prometheus, because it's something that keeps going up, right? So again, imagine that we can have like a customer served, right? And every time we serve a customer, we have another, we have +1. We might have, something that ticks up by more than 1, right? Like if we say we want total value of transactions, right? So every time we have a transaction and we make $15, we add that $15. So it keeps going up, right? But by more than 1 potentially at a time. And it can even go up by floats. Again, like probably you're not monitoring a store. So a good example for a very simple counter is total requests. Every time a request comes in, you increment the counter by 1. That's great. And but if you think about it, potentially you're getting a lot of requests really, really fast, right? Incrementing a number is pretty cheap, but you're not going to write that number to disk, right? That would be way, way too much overhead. Which means counters, very, very typically, they can't go down a little bit, right? If you served 165 requests, you can't undo 5 of the requests and go back to 160. But if your process gets restarted, you go back to 0. So a counter goes up and then 0, up and then 0. And this is like this kind of cliff behavior is going to be like very important later on. As I said, Prometheus expects us to be a web server because it's a web client. And so we need to write a web server. There are many ways to write web servers in Python, as we all know. I wrote my stuff in Pyramid because I'm used to it and I think it's reasonably readable. You can translate what I did here to Flask, Django, Battle, Falcon, Klein, or any other number of web platforms. Here I'm adding a route /metrics, and I attach it to my function metrics web. And I also put in some configuration in the config registry where Pyramid keeps global configuration. And then I create the WSGI app, and that's what's going to be served eventually. But again, your choice of WSGI server, Unicorn, Twisted Web, UWSGI, whatever you want. But first, we need to make sure that we know how to give data to Prometheus. We use the Prometheus client library. That's a PyPI library, but it's made by the Prometheus project. It's part of the Prometheus org on GitHub as they push to PyPI. And you know, let's write a really simple example. This won't even be a proper exporter because we won't even connect to any service. We will invent numbers. I said you can't, but of course, you know, you can do whatever you want. There's no law stopping you. It might not be useful, but you know, no one's stopping you, and definitely no one's stopping me. So I'm going to build a completely useless exporter that like just invents numbers, but it will have all the functional bits and pieces of exporters, and then we'll figure out how to actually wire it to something real. So Prometheus works on the basis of collector registry. There's a default collector registry that I really don't like using for all the usual reasons you don't want to use a global variable. So I create my own collector registry and put it in Prometheus registry, and then I create two metrics. In this case, one of them is going to be a gauge, and it's going to say level, because it's not going to measure anything real, but it is the level of something. Not really. And we're also going to set a good example. And I want to kind of focus on that for a bit, while I'm talking about setting a good example. Why are you writing an exporter, right? Like, maybe I should have started with that, but like, why write an exporter? Right? It's work, right? It's hard work. You're going to have to debug it. You're going to have to maintain it. Why do that? Clearly, I think, you know, there are good reasons to do that. I do that. I find myself doing it quite often. But let's think about why. The only reason to write an exporter is because you have a service that someone needs to monitor. If nobody cares about that service, why do you care? You know, you're also someone, right? Potentially it's you. Potentially someone else is caring about the service, and you're only writing the exporter. It doesn't really matter. Someone, you, someone else, your friend, your colleague, your you know, whoever hiring you as a contractor cares about that service. And why do they care about this service? Because they care about observability. Why they want to know if the service has a problem. Now, that means they A, care about the service, and B, even more importantly, they care about the observability of the environment. Because again, if they didn't care about the observability, they would just SSH into the service and figure something out when it goes wrong. So why is that important? When you're writing an exporter, you're adding something to the environment, right? You're adding your exporter to the environment. Now you've added another component that, you know, potentially can behave in weird ways. And they've already proven that they care about the environment by, you know, getting you to write the exporter, whether it's, you know, you proving it or someone else. Which means you should probably make the exporter monitored. Now, luckily, you already know how to make something monitored, right? Prometheus is anyway going to connect to you, grab numbers, and show it to people. So you should keep metrics yourself and send them to Prometheus appropriately. This is really, really important, right? We need to send metrics to Prometheus about ourselves. And this is what I mean by setting a good example, right? Like, you need to also be a good participant in that monitoring system. In this case, I'm not a great participant because I am limited by the size of slides. So I'm only going to keep one counter of myself, and that's going to be the total hits. In real life, I would actually be keeping request latency and exporting it as a histogram, but I don't want to, you know, put too many details here. But remember that, you know, and if you have more things that you're going to do, you should probably keep metrics of those, and again, send them to Prometheus so that you can, you know, put counters on them, make sure that you have alerts, dashboards, whatever it is that you usually do with Prometheus. Put it on your big TV screen in the office when people go back to offices. So now that we've done it, we need to write the actual web function. In Pyramid, it's just a function that takes a request and returns a response. In most cases, it's something along the lines of that, but in Flask, it also has a decorator and stuff. Here, we don't need the decorator. It's just a function that takes a request, returns a response. And we put most of the logic related to actually Prometheus in the update function that we'll get to later. For now, let's just focus on, like, okay, let's say that, like, you know, we already have all the right numbers. How do we give them to Prometheus? So the Prometheus client library has a function called generate latest that takes a collector registry and returns to you a blob of byte. That blob of byte is what you should be sending to Prometheus, and it uses it tells you which content type it uses, which it exports as a variable content type latest, which you should tell Prometheus to expect. This way, Prometheus has backwards compatibility. If you're using an older version of the library, what the library thinks is latest is maybe not the objectively latest, but Prometheus will get, this is version x.y, and will send to it. You don't have to care about the format. Again, Prometheus client will do all this hard stuff for you. All you have to do is just make sure that you send it to Prometheus appropriately. So you send it to Prometheus, but how do you actually shove the data into the registry? Well, we're going to do it in the update function. And in this case, like I told you, this is not going to be a very interesting exporter. It's literally just going to be something that gives you a random number, but it is going to increment the hits. So the hit counter, ironically, is real, but we're not really monitoring anything. But this, I want to focus on the fact that this is already like a full-fledged thing that Prometheus can connect to and grab data. That data might not be useful to anyone for now, but this is data that Prometheus can intake. So this is great, but again, my goal was to write a Prometheus exporter, so I probably should talk to something and grab numbers out of it. So this is how it's going to look, and you can see that the hits created, and we're going to talk about the hits created. This is a little bit of Chekhov's gun. I'm going to get to it later. But for now, let's connect to a real service, except that's really hard. Most interesting services already have pretty good Prometheus exporters. Originally, I thought about finding like something really, really obscure and writing a Prometheus exporter, but even obscure stuff by now have reasonably good exporters. I'm definitely not going to do better than those in the barely 30 minutes I have to talk to you folks. So instead, I'm going to write my own service. Luckily, there's RFC 867, which is a daytime service, possibly the least useful internet protocol of all time. It is an internet protocol where you connect to it and you say nothing, and it will give you the day and the time in human readable way. So in the beginning of the internet, as you can see from the number of the RFC, it's just 40 over the first email RFC, right? So it's pretty old. Someone thought that in spite of having a pretty good computer with probably a halfway decent clock on it, you're going to want to connect to a remote server and see the time. Not in a way that there's a different RFC, I think 865 or something, for machine-readable time. This is not for machines. This is for humans to literally type telnet, or I guess in modern times, and see. It's supposed to be running on port 13, but I didn't want to run it as root, so I'm just going to write it on port 1113 as a reminder for the real port. And it will give you, now you see when I wrote the slide, it literally just gives you the time and the date, not even in, it doesn't even tell you the time zone. It's literally the least useful protocol you can imagine, but it is a real protocol, and pretty easy to implement. So I decided to implement it, or more correctly, still twisted implementation of it, and wrap it in something that also keeps metrics so we can connect to it. But now I have a confession to make. I told you a bold-faced lie when I said exporters can't do magic and have to rely on the numbers from the service. I did tell a lie. It's not a big lie, but it is a lie, because we can do what you might think of as exporter judo, where usually you'd say, I wish the service already supported Prometheus natively and I wouldn't have to do anything. But here, even though you have to do something, you can get something of the fact that the exporter sits outside of the actual service, because it can connect to the service, send a synthetic query. Luckily for daytime service, a synthetic query is nothing. But if it's a web service, maybe you actually want to do a get / to some API point or some status endpoint, and measure the latency of that. This is really good information. Again, it might not be representative of real customer latency, but at least it will be somewhat sensitive to the load the server is under, and if the server is really malfunctioning, you'll see that. It's pretty good details. So we can start doing that. So here's something that gives us a real number, right? We could use that where I used the random.uniform earlier. Get the right details in. I'm not going to show all the plumbing here. Just imagine that this function goes where the random function went, and I get all the parameters right. And obviously, I'm going to name it something more interesting than level, like say latency or something like that. And eventually, we'll get really useful information. So now we have, and I want to focus on that because in some sense, we're already done. We have done the thing that we wanted to start with. We didn't have any monitoring of the service. Now we have monitoring of the service. It's not great monitoring of the service. The code I wrote is not honestly like that great. And you really want to clean it up for production. But it's something that's fully functional. And now if the service has a problem, you will see it in Prometheus. And that can send you alerts, show it on the big TV you have, whatever you're doing with Prometheus on the other side. But before we're going to connect to the service to grab metrics, let's kind of dig in a little bit to the counter, right? So we talked about how the counter ticks up until it goes to 0. But if you think about it, if you connect to it in arbitrary times, you won't see 0, right? Let's say that you get like 10 requests per second, and you connect to it every 10 seconds. If it restarts immediately, right? By the time you connect, it already has around 100 requests, right? So from your perspective, it went down from like 2,000 to 100. You're not seeing the actual 0. So to actually make sense of a counter, you want the creation time of it, right? So you create when you start, and then you go up and up and up and up. And then when you restart, yes, you go back to 0, but you also reset the creation time. And you can compare two counters if they have the same creation time. If they have the same creation time, subtracting one from the other means how many hits, or whatever it is that you got in the intervening time. If they have different creation times, they're not commensurate. You can't do any math with them. They're not related. They're literally from different servers. And this is important, right? Like this is a creation time for that server. And if you think about it, your creation time has nothing to do with the creation time of the real counter, right? If you have a service that does export some, say, total hits handled metric, if someone restarts your exporter, that counter didn't reset, but that's fine. You get a few more immeasurable counters than you would have otherwise. Who cares? More importantly, if someone doesn't reset your exporter, but does reset that service, now your creation time is still the same, but that counter went back to 0. And now again, you're kind of implying that these are commensurate counters. So this is not great. And there is no general solution. You want to figure out the real creation time of the counter. If the server exports it. So for example, when I wrote an exporter from a router, it has uptime and current time. And if you subtract uptime from current time, you get start time, and that's that was a good creation time to give. Otherwise, you have to somehow you can dig into the operating system. You can do all kinds of tricks, but you want to actually figure out a good creation time story for yourself. If you want to export any counters, and those are super useful in many queries, and there's a reason why counters are useful. But the other problem is that the Prometheus client library has a counter object, and that counter object assumes that it's your counter, which means it resets when you reset. But again, you're exporting someone else's counter. So I wrote a different class called sidecar counter, probably inheriting from something that is not an official API to inherit from, but what can you do? If they ever change it, I'll have to possibly change my implementation. But the idea that here I have a created time that's explicitly set, so I can actually set the when time. I want to make sure that it's a keyword argument so it's not confused with the value. And the child samples. This is how like the metrics wrapper class works. It's kind of a weird class a bit, but what's important is that like this is not solely documented by the Prometheus client library. I'm using probably an undocumented API, but it does work, and I can set it. And I explicitly set the when, so I will explicitly set the when to whenever that service restarts. So if it restarts, I obviously update it. So in my service, I run a kind of a metrics exporter on port 1111, just so this is a way. And since I knew that I'm gonna have to do the creation time, I wrote like a launched thing, and then you can write something like that to grab it back from ISO into timestamp, and then you use a sidecar counter and you set it, and everything is great. Again, like I don't want to show all the plumbing. You can imagine how that works, or you can see the full code later in my repo. Eventually, it will look something like that. You'll have that stuff in Prometheus. You can look at the numbers. You can look at the graph, but you'll have the data in Prometheus, and you can check it out. So when you think about the metrics, when I did the synthetic stuff, I used the gauge. I could also have used the histogram if I did it a different way, which meant I would connect off a schedule, like every, say, 2 seconds, I would connect and grab like latency, and I would keep them in a histogram. That would obviously be more load potentially on the server, but on the other hand, it would reduce my exporter latency, so that's a trade-off that you need to think about when you design your exporter. There's no right answer for everything, but it is a trade-off that you want to think about. There's also something called an enum, which means if your service has a, for example, it can be in different states. You probably want to export the state. So you can use an enum for that. So I hope that I've convinced you that writing Prometheus exporters is pretty easy, right? I managed to write most of the basic pieces of an exporter over basically a 30-minute talk that also included the theory of that. So it's not a lot of code, and really a minimal exporter can be pretty short and sweet. But why should you do that? Why would you do that, right? So presumably you're using Prometheus or something that's Prometheus compatible that can intake the same thing that Prometheus can take. A lot of commercial monitoring systems now can have Prometheus emulation. So if you want to future-proof against, maybe I'll change which commercial monitoring system I use. I'm going to just write a Prometheus exporter and use our Prometheus emulation. So that's great. But there's a lot of Prometheus exporters out there, pretty much for any service. When I initially wrote the talk, I really wanted to find like a service that I can write a minimal exporter for, but basically any decent thing already has like Prometheus exporters. But that's of course talking about things that exist in the world. Maybe you have an internal service, right? That's somehow written in like legacy, right? You have some weird COBOL thing stuck somewhere, or some weird Java thing that nobody wants to deal with, or something else. And, you can get metrics out of it, hopefully, right? It somehow function. But it's internal, so nobody wrote an exporter for you, and you want to write an exporter. And I find it like a more popular reason is you can do it better, and better is not objective, and this is important, right? Maybe someone wrote an exporter for like that open source service you're using, and made different choices than the choices you made, and those choices were good for them, maybe, and you think you can make choices that are better for you, and whether those are objectively better for all people, they might not, but it's irrelevant. You want to do what's best for yourself. And, maybe it's not worth it, but potentially, it is worth it to put in the time. For example, when I wrote an exporter for CloudWatch metrics, I'm sure there's a million exporters out there. But CloudWatch in AWS has a really, really weird pricing model, and I wanted to optimize the pricing out of my exporter. So there are good reasons to write Prometheus Exporters. Thank you all for listening to my talk, and I hope you have a good rest of the conference. Goodbye.